everyone, in this class we are going to continue our chapter number 2, quality cost management, of which in the previous class we understood what does lean accounting means. Let's just revise that first and then we will continue with our today's topic. So we understood that lean is where you are doing only what our customer values, and other than that everything else is treated as waste. Whether it be waste of money, time and effort, it's pure waste. Everything else which you are doing over and above what is important for customer value. So anything else that does not add value is waste. Now this waste can be of 7 different types. First is excess inventory, overproduction, waiting time, reworks or defects, your unnecessary movement, extra processing, unused talent. All of these are different types of waste which with the help of lean we try to reduce or remove. Now lean says that don't do anything that customer don't value and fix problem at the root. So if you want to remove waste, then you need to fix all your processes where all waste is happening, right? So whenever you are solving their problems, make sure you are solving it from root so that it doesn't arise again. Once a problem is solved, is always solved, no need to look at it again and again. Next, improve continuously. Lean doesn't work that one day we will improve and it's done. You need to do that every day, even if it's a small improvement, no worries. We need to make sure that we are improving every day. Next is lean manufacturing. So when this lean system of doing only what customer values applied to factories, it will be known as lean manufacturing. So the first time when lean was used is in the manufacturing system, and it was used in Toyota production system. After that, it applied to entire businesses or entire function. But first, it got applicable in manufacturing and then only it applied over all the organization. Next, what does lean manufacturing means? Here we are trying to achieve efficiency. Now what is efficiency? When you are producing the product but with less and less resources, that is efficiency. So make products with less time, less inventory, less cost and less defects. Next, improve flow. In manufacturing, we try to improve the flow of your value stream. That end-to-end flow should be smooth without any stoppage in between. Remove waste, whether it be of any kind, you need to remove that. Whether it be waiting time, rework, overproduction, any of these 7 waste, if it's there, remove that. Respect and involve worker, because without worker, you will not be able to implement lean or get the benefits of lean, and you will not be able to continuously improve because they are the one who are involved on a regular day-to-day work. They know where all mistakes or problems are happening. So they are the one who will suggest you that this is the area where we need improvement. So you need to involve every worker, then only lean can work in a continuous fashion. Next is lean management. So while managing your whole organization, if you apply lean principles, that is known as lean management. It changes how managers think, plan, measure and improve the work. How it was happening in a traditional management and how it is happening in a lean management is completely different. Next, focus is on leadership management. Don't become manager for your employees, become leader for them. A leader is the one who does not blame the employees for the mistakes. Leader is the one who serve the people and the processes. Whenever there is a mistake, we try to find out why this mistake is happening. Then we improve our processes and we improve our workers also. We train them so that they can handle those works. Next, focuses on leadership management, we already understood. Next, continuous improvement. Lean is about continuous improvement. So wherever lean is applicable, we will focus on improving continuously. Value stream, we need to focus on value stream. Here also we mentioned, right, that we need to focus on our flow, that is value stream flow. Here also we are focusing on value stream flow. Here we were focusing on respecting and involving every worker. Here also we are focusing on the same thing. So it's same only but applied in a different area. Here we applied in manufacturing. Here we are applying in management. Next, core idea is next process is your customer. So give them what they want exactly. No need to change anything. Exact features as our next processes want, we need to deliver that. Similarly, your previous process is your vendor. So take only what you actually need. No need to take extra. No need to take anything else which does not fulfill the requirements or is not of good quality. Next, lean enterprise is when lean is applied to all the functions in the organization, then it is lean enterprise. Next, shift from old method to lean method. Old method was batch and queue system where units were produced in batch and they will have a queue for processing in the next process. So let's say process A produces 1000 units all at once in one batch. Then this all 1000 units will enter to process B. But in process B, they need to maintain a queue because 1000 units are there, right? So it might happen that all the 1000 units can't be processed together in process B. So they need to maintain a queue, and then this 1000 units batch will be completed by process B and then sent to process C. Think about it, how much time is wasted. When process A is producing all the 1000 units, process B is waiting at that time. Similarly, when process B is producing, process C is waiting at that time. So a lot of wastage is there of time. Similarly, think of the final product. So at the process C also will produce all the 1000 units together and then we'll get 1000 units of final product all together. It can happen that now this final product will be inspected and there are defects. Now what you will do? You have made 1000 units. Defects can be used because all the 1000 units has been made from the same processes, from the same machine, in the same characteristics or features what machine had at that time. So everything is same. So it might happen that a lot of units in this 1000 units are defective. And now you are going to improve your processes after making 1000 units. It's very complicated. It's also a wastage. A lot of defective can arise at that time. And when we follow this batch and queue process, we produce exact same quantity every time. So 1000 units, every time one batch will be of 1000 units. Even if customer wants 100 units, we are producing 1000 units. What is the use of it? You are making extra inventory without any need, right? That is the issue with batch and queue system, that it makes units in large batches in advance, store until customer buys, create high inventory, slow response, and a lot of wastage. And that is why lean method is introduced, which says that single piece flow should be used and pull system should be there. Now, what is single piece flow? So earlier we were producing units in thousands of units per batch, right? But single piece flow says that one process should be processing only one unit at a time. No need to produce over and above that. Now, what happens with this? One process will process one unit, directly it will transfer to process B. No queue because only one unit is there. So this unit will go directly to process B. Process B will process it. No queue again. Directly process C will process it and will get the final product. Now, as we have made only one final product, we can inspect that. If it's not good, we can improve our processes. This is single piece flow and it's a pull system. That means we'll not make in advance. Whenever customer gives orders to us, then only we'll start producing. So produce one item at a time, straight continuous flow process. That means every process should be in a straight line and it should flow continuously without any stoppage in between. As there is no queue, as there are not a lot of quantity coming from one process to another, then there is no stopping in between, right? Less stock, quick response to changing demands. As we don't have a lot of inventory, whenever the demand changes, we can change our system and produce accordingly. There will be no obsolescence because no inventory is already maintained. Cost reduction and quality also improves. This is why lean is useful for the organization. Now, why companies use lean today? To reduce the cost, to respond quickly to the changing demands, because the earlier one was making a lot of inventory which might get obsolete after time. But as the demand is changing, lean is very helpful for the organization because it allows us to change according to demands. To ensure high and consistent quality, we are able to achieve high quality with the help of lean. So it increases quality, reduces waste, and we are able to respond quickly to changing demands. Benefits of lean. So some things get fast and quicker. What all things get fast and quicker? The delivery is fast. Order to cash cycle time is fast. Better. On-time performance is better. That means whenever customer has asked us to deliver the product, we are able to provide it on that time itself. The relationship with supplier becomes better. Our product and services quality become better. More or higher sales we have, a lot of profit we can earn. Inventory turnover is high. Employee morale or retention is high, and working capital is also available. Lower or less. We have less inventory, less space requirement, and less operating cost. And after all of these, what happens? Our customers become happier. Next comes lean accounting. So when you apply lean principles, whether it be customer value, continuous improvement, and respect for people to all accounting and finance activities, then it is treated as lean accounting. Lean manufacturing removes waste in production, but lean accounting focuses on accounting. So every aspect of accounting will focus and try to reduce the cost, whether it be costing, reporting, budgeting, financial statements, and decision-making processes. Companies using lean manufacturing realize that traditional accounting does not match lean. Lean focuses on small batch, continuous flow, focuses mainly on customer pull system, low inventory. It's exactly opposite to what traditional accounting focuses on. And that is why it's important that if your organization is shifting towards lean, you are going for lean management or lean manufacturing or lean enterprise, then it's very important that accounting should also adapt accordingly. You should use lean accounting. Now, what is lean accounting? When you remove waste from accounting processes, that is known as lean accounting. It provides real-time visual info for value stream. Now, our main focus is not our product or service. Our main focus is value stream. What is value stream? End-to-end flow of any product or service. So, let's say if I'm providing a product to my customer and he has placed order for the same. So, after placing the order, till the time we deliver the product to the customer, there is specific activities followed in between. All of these activities become value stream. So now our main focus is value stream, to get the cost of value stream and to get it on a real-time basis so that managers can make a better decision. Now these information which we are providing to management should be visual. That means we'll not make it more complicated as we used to do earlier. No long reports, but the report should be shorter and visual. That means use bar charts, pie charts, so that managers can understand those reports properly. Focus on flow, capacity, and value. Flow, that means value stream flow. Capacity of the organization, that how much capacity we are using in different areas, so that we can also understand, is there any area where there is any bottleneck? What is bottleneck? When you have limited capacity, you are not able to produce as compared to what other processes are able to produce, then that is known as bottleneck. So we can know whether there is any bottleneck or we have excess capacity. And value, how much value we are creating for the customers. Instead of cost absorption, our main focus now is not cost absorption as we used to do in traditional accounting. Now our main focus is flow, capacity, and value. Support managers in making fast, better, and simpler decisions. As we are able to provide real-time information to the managers, they are able to make fast, better, and simpler decisions. Now, when we say simpler decision, it does not mean that only for simple decisions lean accounting will be used. Simpler decision means it's easier for the managers to take decisions now because they are able to understand the data more precisely with the help of visuals. Now, how lean accounting works? Traditional accounting groups cost by departments, but lean accounting groups cost by value stream. We will calculate cost of every value stream. A value stream is the complete flow of activities needed to deliver the product or services to the customer. Now, this customer can be internal or external to the organization. Next, example of value stream: product A value stream, your online orders value stream, repair service value stream. What will be the value stream? So, wherever you are following an end-to-end flow with the help of which you are delivering something to your customer. Now, this customer can be internal or external, then it will be treated as your value stream. Each value stream has its own revenue and its own cost. Now, when we provide services to internal customer, at that time we treat our revenue is equal to cost. We don't want to charge profit from internal customers itself. We are not focusing on how much each internal value stream is earning. Our main focus is to reduce cost at every value stream. Next, supply chain, value chain, and value stream. What is the difference between them? So, supply chain focuses on flow of material plus logistics. That means how material is transported from one place to another. Value chain focuses on value adding activities. Value stream focuses on flow of value stream activities. That means your end-to-end flow through which you are providing your goods or services to the customer. Supply chain works across multiple organizations. Value chain focuses only on the entire organization. Value stream focuses on product or services only which we are providing to our customers. Supply chain provides right product at right time. Value chain's goal is to gain competitive advantage, but value stream wants to save waste or reduce the waste, right? Save cost or reduce the waste. Features of value stream: costs are calculated weekly, not monthly, not quarterly. We'll calculate weekly so that we can get early feedbacks. No differentiation between direct and indirect costs. Both of these costs will be, if they are related to value stream, they will be treated as direct cost. No bifurcation on the basis of product. Bifurcation between direct and business sustaining cost will be there, and direct cost will be the one which belongs to value stream. Any cost, whether which you earlier used to think as overheads, are now, if they are part of value stream, they will be treated as direct cost. Anything which needs allocation or you think you need to divide it between different value stream, then those costs will not be divided, they will be treated as business sustaining cost. Value stream includes everything required to produce or deliver goods or services. It includes material, labor, support staff, machine and equipment, facility and maintenance. Everything which comes in value stream will be treated as cost of direct cost of value stream. Now, what lean says, if we are making some product, there might be some inventory, even if we don't want to make it in lean, but there might happen that there are some inventory. Then what will happen? Lean says that we refuse to capitalize labor into inventory. We will not capitalize labor into inventory. We will not absorb overheads to unsold units. So all of these costs will not go to our inventory. Why? Because our main aim is not to show profit just because production increased. We know that in traditional accounting it used to happen that whenever inventory increases, profit increases. But the thing is, we have not sold it yet. Then why our profit is increasing? Lean understood this and decided that will not increase our profit just by increasing the production, and hence will not include our labor or overheads in inventory. Will, if they are incurred in the current period, they will be charged in current period itself, even if there are finished goods inventory. So how finished goods inventory will be valued? Only on the basis of material cost. Managers get a clear picture. How managers are getting clear picture? Because managers are able to see only the cost which is related to value stream. Anything other than that is treated as business sustaining cost and hence not important for decision making related to a particular value stream. Hence, if they want to decide about a particular value stream, they can focus on their cost itself. Managers see only the cost they can control which is related to value stream, and they can make better, faster and easier decision making. So these are the features of value stream. Costs are calculated weekly. No differentiation between direct and indirect cost. Value stream includes everything required to produce or deliver goods or services. Managers get a clear picture. Next, what is business sustaining cost? Cost which does not belong to any value stream will be treated as business sustaining cost. It can be anything like CEO, corporate, HR, legal department, general admin, sales, marketing, distribution. If they are done together for all value stream, then they will be treated as business sustaining cost. Now these costs are kept separate and hence don't hide real performance of each value stream. We are able to see what each value stream is performing, how each value stream is performing, as these costs which are related to every value stream has been kept separate. 3 principles of lean accounting are customer value, continuous improvement and respect for people. What lean accounting helps fix? It helps us remove waste in accounting processes. Whatever waste is there in our accounting processes, we are able to reduce them or remove them. Improves visual reporting rather than long reports. We are mainly focusing now on visual reports which are easy to understand for our managers. Shift accounting team's role. Earlier, our accounting team played a role of data entry. Now they are playing a role of advising or consulting, where they are consulting, advising the managers, employees on what to do and what not to do. What lean accounting tries to show? It shows us flow of work in value stream, how work is flowing in the value stream, how much extra capacity we have, and cost of different decisions. Whatever decision you are taking, there might be different alternatives, like, right? On the basis of these alternatives, we select one alternative. So how you are deciding that this alternative should be selected? We got the cost of different decisions from lean accounting, through which we decide that. Benefits of lean accounting: creates capacity in accounting. Now our accountants are not fully utilized in doing data entry work. They are free, and this free time can be used for useful works. helps in continuous improvement, provide reliable and relevant information for decision making, and use accounting skills to coach or advise others. Whenever there is need of any advice to anyone, then our accountants can provide that. Done. Next is principles, practices, and tools of lean accounting. So the first principle is lean and simple business accounting. So when we are following lean accounting, we want to make it lean, right? What does lean means? Waste free. So we want to make it lean, we want to make it simple, and that is why we are using lean accounting. So how to do that? Continuously identify and eliminate waste wherever you find it and simplify your processes. So to make it lean, you need to remove the wastages, and to make it simple, you need to simplify your processes. What all tools we will use? Value stream mapping, Kaizen, and PDCA. Accounting processes should be such that they should support lean transformation. So the whole organization is shifting from the traditional method to lean method now. And if that shift is happening, then accounting should support that shift. How accounting will support lean transformation? With the help of tracking all the lean improvements which organization is having, plus whatever improvement is happening on an operational perspective, what is its impact in financial perspective. So first, we will track our lean improvements, then what these lean improvements are having financial impacts, we'll see that also. That is the practices. Next comes tools. So we'll use performance measurement linkage chart, which shows us what impact it is when there is any improvement in value stream, what is its impact in the whole plant, and what is its impact in the company as a whole. Next, value stream performance board shows us what are our targets and how much we have performed till now. Box score is a 3-part decision making tool which shows us what is the scenario of operational, financial, and capacity before applying lean and after applying lean. So these are different ways through which we are tracking what is the impact of lean improvements in operational perspective and financial perspective. Next, clean and timely communication of information should be there so that it becomes easier for the managers to read those information and to use those information for decision making. So what all practices are there? First, financial reporting should be simple and understandable. Use visual reports, dashboards so that it becomes simple to understand. Decision making should be actionable. For decision making, you should provide actionable and real-time insights. For doing all of these, we use different tools. For financial reporting, we use simple plain English statements, and the statements or accounts should be cash-based, not accrual-based. Visual reports, for making visual reports, you can use visual performance board, and for decision making, use incremental cost and profitability analysis. No need to calculate the whole cost of everything. Just calculate the extra or incremental cost and incremental profit, because they are the only relevant cost. The cost which has already been incurred is of no use. The cost which we are going to incur, the revenue which we are going to earn, the profit which you are going to earn is the decision maker here. Next, planning from lean perspective. Now, if you want to plan from lean perspective, first do planning and budgeting which aligns with lean. To align your planning and budgeting with lean, you can use Hoshin policy deployment, which says that your company's goal should be aligned to department goal and department goal should be aligned to team goal. Hoshin policy deployment helps us to do that. SOFP, this is sales, operation, and financial planning. We align all of these together. How? So first you find out what is the demand of your product. Then find out how much you can produce using your operations. Let's say if demand is 10,000 but you are able to produce only 8,000, then you need to increase the capacity by 2,000, right? To increase this capacity, you need finances. So aligning your demand, production, and finances is SOFP. Next, impact of lean improvement. What is the impact of lean improvement? To see that, you can use value stream cost and capacity analysis, current and future state mapping, and box score for lean changes. Next is capital planning, where you are deciding how much investment we should do in our capital assets. For this, you can use capital expenditure box score plus 3P, which is production, preparation, and processes. Next is invest in people. Here we can use performance tracking in employees so that we can see what all benefits are there by training the employees, how much training we are providing to them, profit sharing. We can also share profits with them so that they support this lean management in the organization. Strengthen internal accounting control. Your accounting should also be good enough and controlled enough with less risk. And if there are any risk, then there should be the measures which we can use to control that. Now, when we say control, it doesn't mean that after doing all the accounting, now we need to control that whether everything has been done properly or not. We are saying here that control should be built into your processes. That means no need to do control afterwards. While you are performing your job, the control is happening with that itself. Now for that, you can use some softwares so that it becomes natural, not burdensome for the employees. Here are different tools which we can use. Transaction elimination matrix, which says that we want to make the control but not complicated. It should not happen that there are a lot of checks or a lot of approvals are happening. Make sure you are eliminating extra approvals, extra checks, because we want to control but we don't want to make it burdensome. Process map with SOX control. Here we are mapping our risk and control for every step in our process map itself. Okay? Now, inventory valuation. As we have less inventory here, so your inventory valuation should be clean and simple, not complicated. So value inventory only when there is a need. No need to value it every time. No need to use perpetual inventory system which values inventory every time whenever there is a sales, purchase or issue. No need to do that here. Simple valuation methods should be used because inventory is very low. So no need to do overhead allocation or labor cost allocation. Only material cost should be allocated to inventory. Product cost based on actual flow itself. No standard cost allocation will be there. Only on the basis of what actual cost has been incurred, we will value our inventory. Now these are different types of principles and tools and practices of lean accounting. This was everything we understood about lean accounting in previous class. Now let's start with our today's topic, and that is Six Sigma. Now this Six Sigma topic, if I show you how Institute Study Mat is given this topic, it will take around 10 to 20 minutes to understand that. But the thing is, then also you will not get an understanding that what actually Six Sigma is, why organizations want to apply this, why we are following a specific kind of method in Six Sigma, how Six Sigma is able to achieve 3.4 defects per million opportunities. That means if you are making million products, then only 3.4 defects will arise. How we came to that number 3.4? You'll not able to understand all of these if I tell you what institute has given in their study mat. Now you'll say that, ma'am, what is the need of understanding all of these? We'll learn, we'll remember everything, whatever institute has given. No need to understand in deeper manner. So let me just tell you one thing, that this topic is not only important from your exam point of view, it is also important in your practical life. When you are going to work in an organization, every organization today wants to apply Six Sigma and get benefits of it. If you know what Six Sigma actually is, then you will be the one preferred there, because most of the people who are actually applying Six Sigma in the organization, they also don't know what Six Sigma actually is. And you will be the one who knows that in a really good manner. And that is why you need to understand this. This is very important from your practical life perspective also. So now I have told you what is the importance of it. Now you need to make sure that you're watching this video all at once. No need to break it in parts. Watch this video all at once, then only you'll be able to understand it. Plus, it can happen that at some point you are feeling that it's going heavy. Let it be. Then also watch the complete video, because at the end of the day, at the end of the video, you will understand everything. Everything will become clear to you. Done. Now with that, we can start our topic, Six Sigma. So we are going to first understand that how Six Sigma was evolved with time. Before Six Sigma, we had statistical quality control, then came process capability, and then came Six Sigma. But before statistical quality control also, there was something which is known as inspection. So whenever someone says quality at that time, they were only referring to inspection that is done at the end when we have got the final product. We already understood what inspection is, right? When you are checking the final product, whether it's good or bad, that is what inspection is. It will check if the product is bad, then it will be treated as defective product. And if we can rework on it and correct it, we will do that. If we are not able to do that, we'll just scrap that product. And that is what inspection does. Nothing more, nothing less. Let's understand what is written here. Before modern methods, industries depended entirely on inspection. They mean quality is equal to inspection at that time. Workers checked product at the end. If defective, they threw them or reworked on them. Problems with inspection only approach. Inspection only approach means you are only applying inspection as a quality control thing. You are not doing anything else. Then what is the problem with it? It's too late. You are checking the final product, which has already incurred all the material, labor, and other expenses. Now you are checking whether the product is defective or not. By checking it, you are able to make sure that the defective product is not going to our customer. But the thing is, you have already incurred a lot of expense on it. So it becomes too expensive for the organization because all the expenses have already been incurred in it. Now we are throwing that product. No understanding of why defects occurred. In inspection, our focus is not on understanding that why this defect, we need to cure it, we need to make sure that this defect doesn't occur next time. We are not focusing on that. Our focus is not on finding why defect occurred. Our focus is only on finding the defects. No prediction of process behavior. Why are processes behaving like this? Why so much defects are occurring? Nothing has been thought by the organization when they were using inspection only approach. And that is why statistical quality control was needed. Why? Because inspection focuses only on finding out defective products at the end, when the final product has been produced. But statistical quality control says that if you want to control your quality, you need to apply that quality control in the process itself and not after completion. That is why statistical quality control was introduced, because inspection was very expensive for the organization. Just inspection approach was very expensive because the product has already been produced and now it is treated as defective product. So quality should be controlled during the process, not after. Who said this? Dr. Walter A. Schuhart. He said in 1920 that if you want to control quality, then you need to control your processes and not after, because inspection will not be able to control quality. This gave birth to statistical quality control, and that is how statistical quality control was introduced. Now, what is statistical quality control? First, though, we are going to control our processes, plus we are going to use statistics to control our processes so that we can have good quality output. Now, how this will be done? Statistical quality control uses control charts for controlling the output. Now, what does control chart does? First of all, you need to take samples in your batches. So let's assume I'm producing 1000 units in one batch. So I'll take 20 units out of it as sample and we'll check it. No need of exact 20 units. You can take 30, 10, whatever you think will justify that all the 1000 units are good. If the samples are good, you can take that much sample. It's enough. If you're making in batches of 1000 units, then you will take 10-20 units. But if your production is happening continuously, it's not in batches, then you can take the samples every hour. Every hour after producing the units, you will take some samples and check whether the samples are good enough or in limit or not. Now, how to check the samples are good or not? So you need to understand that even if you are following completely automated processes, then also the machines are not able to produce exact output every time. So let's say if you want the output of 2 kg, then the machines will not be able to produce 2 kg output every time. It can go somewhat upward, somewhat downward. So you need to set a limit that how much up is okay and how much down is okay. So let's say our organization has said that if it goes to 1.9 kg, it is good enough. We can use that product and our product will be said as stable product. Next, if it goes to 2.1 kg also, then also it will be treated as a stable product, no issues with the product. So these are set as limits. This is the center line. This is our average which we want for most of the product. But it can happen that product goes to the lower limit, lower control limit, and it can also go up to upper control limit. Now we need to make sure that our product remains in these limits, not going above it and not going below it. Why? Because if product comes in between of these limits, it is treated as that our process is working normally. But if it goes above it and below it, then it is said that there is something abnormal, due to which the variations are special. So variation between this limit is treated as normal, but if it goes above and below it, then it is treated as special variation. Now how it is shown in control charts? In control chart, we will have one center line, which is our average 2 kg. Upper control line is how much up is okay, that is 2.1 kg, and lower control limit is how much lower is okay for us, that is 1.9 kg. If the output is between these limits, it is treated as normal process variation, but if it goes outside these limits, then it is treated as special cause variation, and that is how samples are checked. So if all the samples are between these limits, then we will say that the whole batch is good. But if in sample there is some output which goes outside, then we can say that there are defects in this particular batch and we need to correct our processes so that this defect doesn't happen again. Done. This is how our control charts work. Now think about it. If your process follows a 5-step or 10-step process, then how you are going to apply statistical control? Are you going to apply this on every step, after every step, or you are going to apply it after some steps and not every step? Or are you going to apply at the end? So at the end, though, it's very less chances that we are using statistical quality control because inspection is there. Inspection is going to check our end product. But statistical quality control will be applied between the processes. But are we going to check every step or we are going to check some steps? Let's understand that. So let's assume we are manufacturing a metal bolt. So to manufacture metal bolt, there are 5 steps followed. First, we will cut the rod into short pieces of which we can make that metal bolt. Then we'll shape that rod on the basis of how bolt looks like. Then we will do threading. Now what is threading? So have you seen those metal bolts where spiral is there? Due to which you are able to tight that nut or tight that bolt? That is threading. Next comes heat treatment, where we make sure that our bolt is hard enough so it can be used in walls also. Then comes final finishing of the product. This is the 5-step process for making metal bolt. Now the question is, where you will apply SQC? You will apply SQC at any step where quality characteristics is measurable and critical. So quality characteristics should be measurable. Then only I'll be able to set this upper control and lower control limit, right? Plus, it should be critical. It should be at such step where variations are high so that we can control those variations. How SQC works in multi-step process? So SQC applied at critical control points, not blindly at every step. So we understood that we are not going to apply it at every step blindly. We will only apply at critical control points. Now this critical control points can happen after every step. Then though you will apply at every step. But if it is not at every step, then you will apply only at the critical control points where variations are heavy, where you need to control those variations. Now, at each important stage, wherever we are using statistical quality control, first we will identify measurable quality parameter. That means we will set our upper control limit and lower control limit. Take samples at intervals so that we can check whether our sample is coming between these limits or not, and that plot control chart. And if there is normal variation, good enough. If it is special variation, then you need to check your process. There might be some mistakes or problems with the process itself. Now, let's apply it step by step. First, we are applying it at cutting stage. So, quality characteristics, length of rod should be 50 centimeter plus minus 0.5 centimeter. That means your center line is at 50 centimeter. Your upper control is 50 plus 0.5, that is 50.5 centimeter. And your lower control is 50 minus 0.5, that is 49.5 centimeter. This is my upper control limit. This is my lower control limit. Now, if my rod comes between this limit, then it will be treated as normal variation. But if it goes outside this limits, then it is treated as a special variation and you need to adjust your cutting machine. Next, we didn't apply the control at step 2 because there was no requirement as such. Now we are applying directly to step number 3, where we are doing threading or that spirals in our bolt. Now for threading, it matters that how much depth it has and what is the pitch of it. So we will take sample every hour, plot on control chart. We'll also set the limits of it and then plot the samples on control chart and check if the variation is normal inside our, between our upper control and lower control limit, good enough. But if it goes outside those limits, then there is a need of checking that particular process. Done. Now, next we are applying at step number 4, which is heat treatment. Now, heat treatment is for making that particular board hard enough to be used in balls. Now, for that, we are using a furnace, which is a heating system. If temperature fluctuates of the furnace, then the hardness will also fluctuate. And that is why we are not looking at the final product. That is how hard our product is. We are looking at the furnace temperature itself. So we are not looking after this step. We are looking at the process itself, that whether the furnace is providing the same temperature or similar temperature or not. If temperature is between upper control and lower control limit, good enough, your product will be hard enough and can be used for the particular purpose which we are making it. And if it goes outside it, then there are some special causes due to which it is happening and you need to control your furnace temperatures. Done. Now, important concept, SQC is not about counting steps. You will not apply at every step randomly. You will check whether it is critical or not, then only you will apply it. So in a 5-step process, it can happen that you are applying 3 separate controls, or you can also apply 4 different controls if there is a need of it, or it can also happen that you are only checking at the final stage. But normally, SQC is applied for checking the process while it is in processing stage, not only at the final stage. Done. Now to remember this process of SQC, we are taking one example of making biryani. So I am making veg biryani. You can decide whatever you want to make, but I am making veg biryani. It follows a 5-step process. First, we will wash rice, then we'll boil it, prepare our masalas, layering, and final steam cooking. Now think about it. If you taste your biryani only at the end, then you are doing inspection and it can lead to mistake that your biryani is too salty, too with a lot of masala, your rice is not cooked properly. All of these can happen if you are checking only at the inspection stage. And that is why it's important that you need to check biryani in different point of time. After boiling, check the smoothness of rice. After adding masala or salt, check whether it's added properly or not. And after final steaming, now also check the product. So when you apply the checking after every process or after every important processes, you are following statistical quality control. If you notice, one more thing is there. When you are checking your rice, you'll only take some samples. You are not going to eat the whole rice in between to check whether the rice has been made properly or not. Right? You'll take some samples as we do in SQC. So this is a very good example to understand and remember how SQC works. Now let's move forward. What SQC really does. Now let's look at what our book says about it. So what SQC really does? SQC uses statistics to find out whether the process is behaving normally or not. So we are using statistics, we are taking some samples, and on the basis of it, we are deciding that our whole process is working normally or not. There can be variations in processes, and these variations can be of 2 types. The first one is normal variation, which will happen in your process. You can't stop that. These are natural, always present, and process is stable if only common causes exist. If there are only these normal variations, then it is treated as your process is stable and everything is working properly fine. But if the variation goes outside upper and lower control limit, then it is treated as a special variation and it is happening due to something specific going wrong in your processes. You need to identify what is wrong in the process and eliminate that. then only you'll be able to make sure that your product is within those limits. Schuhart created the control chart to separate these two variations. Hana? So we have already seen the control charts which separates this two variation. If the variation is between upper control limit and lower control limit, then it is normal. But if it goes outside that, then it is treated as special variation. So a control chart has center line, upper control limit and lower control limit. Now this thing can come into your mind that how organizations will decide what will be the upper control and lower control limit, because center is the average, what normal or average output we are getting, that will be center. But how upper and lower control limits will be decided? So there is specific formula for the same. We are not going into that, but we use some maths, we use some formula to set this upper control and lower control limits. So if all points are between UCL and LCL, then it is treated as process is stable. Everything is going in a stable manner. But if it goes outside, then there are some assignable causes which we need to investigate and fix it. Otherwise, our process will not be able to produce stable output. Purpose of control chart. We want to keep our process stable, and that is why we are using control charts. It detects problem early. We are not waiting for getting the final product ready and then inspecting it. We are checking it after every process, and that is why we are able to detect our problems early. Prevent defective units. Prevent your final product to become defective as you are checking after every step or some critical steps. Make the process predictable. We are trying to make our process predictable so that it comes inside those limits only. And that is what is aim of control charts. Now, what control charts cannot do and why we moved from statistical quality control to process stability? The reason is control charts can't tell you whether your product is meeting customer specification or customer requirements or not. Think about it. Your upper control and lower control limit also has been set with some specific formula. You're not checking what your customer wants. What is the range of the product which customer, if he gets that, he's okay with that. You don't know that. And you are not checking that in quality control charts. Next, whether the process is capable or not. Whether your process is capable enough to produce every time or produce most of the time what our customer wants. We don't know that. Whether defects are near zero, we don't know that also. And that is why the next stage was required. Because statistical quality control can make your process stable, but it can't tell you that the stable process, the product which is produced here, is actually able to fulfill our customer requirements or not. Are we able to do that most of the time or not? We don't know that, and that is why process capability was introduced. Now, the next stage is process capability. Now, once a process is stable using SQC, companies started asking that even if our process is stable, is our process able to produce what our customer wants? Because think about it, your customer doesn't care whether your process is stable or not. He cares only about one thing, that whether your product is able to fulfill his requirements or not. If that product is able to fulfill the requirement, he'll buy that product. Otherwise, he'll go to some other competitor. Control charts only check process capability. The chart which we were using earlier, statistical quality control, was able to check only the process whether it's stable or not. But they do not check whether the performance or process performance against customer requirement. Whether we are able to produce what our customer wants or not, we are not able to check that in statistical quality control. Example, if a customer wants 160 plus minus 4 gram, that means he is happy if you give the product from 156 gram to 164 gram. But if it goes above or below that, he will not be satisfied and that product will be treated as defective product. It's of no use because it is not able to satisfy the customer, right? But is this limit your upper control and lower control limit? Answer is no. Upper control and lower control limit are set by some maths formula. It doesn't check what your customer wants. The upper control and lower control limit can be completely different from what your customer actually wants. And these limits which are set by the customer are known as lower specification limit and upper specification limit. These limits, which are control limits, are set by some formula which makes sure your process is stable. But to see whether you are able to fulfill the customer requirements, you need to use some other limits which is set by the customer, which is known as lower specification and upper specification limit. If a customer wants weight between this, then control charts cannot tell whether individual product item fall within that band or not. Because the first thing, your control chart use some other limits, some other upper and lower limits, and your customer can have some other limit. Plus, your control charts only check samples. But by checking samples, are you sure that every product which is made is able to come under that limit? Answer is no. And customer don't care whether you have checked the samples or not. He cares that the product which he is getting should be perfect. And that is why we need to check individual item. That individual item should be within that band. And this is not done by statistical quality control. Therefore, the next question arises, does the natural output of the process fit inside the customer allowed limit? Now we understood that customer wants the product between these specification limit. Now we need to check whether are we able to produce the product inside this limit or not? Are the natural output or the most of the output which we are generating is inside this limit or not? And to check that, we use process capability, which checks two things or which takes help of two things to find this out. First, we will set the specification limits, upper specification, lower specification, which is set by the customer. And with that, we are also going to use natural tolerance limits, which is voice of the process. Now, what is this natural tolerance limit? To understand this, let me just draw a chart. Similar to that of what we were drawing in control charts, we are drawing here also. But there we were using lower and upper control limits. Here we are using upper specification limit and lower specification limit. We need to make sure that most of the output our organization is generating is coming inside that limit. Because if the output goes outside it, it will be treated as defective product because it is not able to satisfy the customer wants. And the product which is not able to satisfy the customer wants is defective product. And that is why we want that our product should come inside it. Then only our process is said to be capable process. Now to make sure that your product comes inside this, what you need to do? You need to take help of normal distribution curve. Let me just draw it here. This is our normal distribution curve. Somewhat it looks like this. It's a bell-like curve, which, let me just draw it again. It's looking very bad. Now, I am also not liking, then how you will like that? Now it looks fine. So this is the curve. This curve is divided into two parts from the center. So if you notice, this is our upper specification and lower specification limit, and this is the average. So let me just take this only. 160 is the center. 164 is the upper limit. And 156 is the lower limit. So this center line cuts this normal distribution curve into two equal parts. This side and this side will have exact same area. And as we understood that this 160 is average, average can be denoted by mu. Mu is mean. Now, if you notice, in this normal distribution curve, most of the data will come in this side. Are we going to plot the data here? Answer is no. We are going to plot all the data of the products in this chart. But from here, can you understand that most of the data comes here? Answer is yes. If this is the average, then most of the data is going to come here only, near our averages. But it can also happen that the data comes in the right side or on the left side of the average. But that data will be lesser than what is coming between or near the averages. Done? Now, whenever we move from mean, that is average, whenever we move on the right or the left side, is there any variation, and that is why are we moving? Answer is yes. If you are able to produce the output on the basis of 160 gram itself, then though there is no variation. But if the output goes somewhat here or somewhat here, that means there are variations. So if I go one variation this side, or two variation this side, or three variation this side, how will I denote the variation? To denote variation, we use the standard deviation sign, which is also known as sigma. So this sign can be called as sigma or standard deviation. It shows us how much variation is there. So this is one variation, this is two variation, this is three variation. The variation can go up and it can also go down. So for this side, we use -1 variation or standard deviation, -2 standard deviation, and -3 standard deviation. Now you can tell that, ma'am, why you have drawn only up to 3 standard deviation here and -3 here? The reason is this normal distribution curve has a table, which is also known as normal distribution table. Now this table shows us that if you go 1, 2 or 3 on this side and 1, 2 or 3 on this side, what will happen? So that Z-score table or the normal distribution table mainly tells us the value or the percentage of output which will be covered by this 1, 2, 3. Now what this 1, 2, 3 is known as? These are our Z-score, with the help of which we can know that how much output will be covered if I go up to 2 standard deviation or up to 3 standard deviation. This Z-score table tells us that when you go on the right side, up to 3 standard deviation, 49.865% of the output will be covered. And as we already understood that the area of this normal distribution curve is exactly equal on both sides. So if up to 3 standard deviation, here it is 49.865%, here also it is going to be 49.865%. So if you total both of them, it will cover 97.3%. That means if you are able to cover up to 3 standard deviation here and up to 3 standard deviation above, then you are on total 99.73% of the output is already covered and inside this specification limit. And that is what we want. We want that most of our output should come inside this specification limit, because if it goes outside, then it is a defective product. So if you are able to put a normal distribution curve of 3 standard deviation inside this specification limits, then you are able to achieve 99.73% of the output as per the specification limit set by the customers. Now you can ask that, ma'am, what does this standard deviation is? Is this standard deviation is already known? We are using every time exact same standard deviation? Answer is no. For every data, standard deviation will be calculated separately, and there is a specific method which we use to calculate standard deviation. You might have studied about this in your lower classes. Let me just show you how it is calculated. So to calculate standard deviation, first we will take all the output or all the percentage or value of the output which we have generated. We'll take average of it. So average is coming to 100. This is our mu. Then we'll calculate x minus mu, that is the x value, and your average. We will minus that and we'll do square of it. After doing square, we'll calculate the total of it, which is denoted by sum of x minus x bar ka whole square upon n. N is your number of output which you have taken. So we have taken 5 outputs and x minus x square's sum is coming to be 10. Then you calculate root of it, which is coming to 1.41. This is how standard deviation is calculated. For every output, standard deviation can be different. And that is why how this particular normal distribution curve is drawn, this can also be different for different outputs. It can be drawn like this, or it can come to a little near, or it can go to a little farther. So it can happen. according to what standard deviation is. So we need to make sure that our standard deviation is such that we are able to cover up to 3 standard deviation inside our specification limit. Then only we will say that our process is capable to produce the output as per customer's specification. Now, process capability analysis compares what the customer requires, which is the specification limits, and what the process naturally produce, which is the tolerance limit, natural tolerance limit. Specification limit is voice of customer, said by customer, applied to every individual product. Statistical quality control was about samples, but when we are in process capability, we are checking every product, because every product should match customer's requirement, otherwise they are not going to buy it. Natural tolerance limit is voice of process based on mu plus minus 3 standard deviation. When we say mu plus minus 3 standard deviation, we mean that in the right side we are going up to mu plus 3 standard deviation, and in the left side we are going up to mu minus 3 standard deviation. This shows natural variation of all individual units. Capability indices shows how well the process fit inside specs. So to check whether your process is able to produce as per the specification limit set by the customer, we use capability indices. So what capability indices tells us? It tells us if the process variation is less than customer tolerance, then process is capable. Now what does it mean? Process variation is denoted by your natural tolerance limit. So if your mu plus minus 3 standard deviation is inside your specification limits, that means your process is capable. But mu plus minus 3 standard deviation goes outside the specification limit, then your process is not capable to fulfill the requirements of the customer. This is what is written here. So if process variation, that is your natural tolerance limit, is less than customer tolerance, good enough, process is capable, but it goes outside the specification limits, then your process is not capable to produce or fulfill the requirements of the customer. Process capability introduced an important understanding that a process can be perfectly stable. Perfectly stable process means which is able to fulfill the limits set under statistical quality control. That upper control limit and lower control limit is satisfied. Then the process will be treated as perfectly stable process. But then also, is it guaranteed that will it be able to fulfill the requirements of customer? Answer is no. And that is why process stability is checked. Now, this is how this diagram is drawn. Let me just correct some of the things. This is our upper specification limit and this is our lower specification limit, and natural tolerance is mu plus minus 3 standard deviation. But the thing is, upper specification limit is your variation is going up, and that is why it should be positive. You should also make this change in your book. But when we go to lower specification limit, it is lower than average. So it should be in minus. Done. This is our upper specification, lower specification limit. This is our target, and natural tolerance is mu plus minus 3 standard deviation. If your individual product is inside this, good enough. But if it goes outside and it also leads to your 3 standard deviation shifting from outside your upper specification, lower specification limit, then it leads to process not capable to fulfill the requirements of the customer. Done. Next. Here we mentioned that this will be checked for individual product, not only for samples. Now, this is your normal distribution curve, and if you notice, if you go from mu to 1 standard deviation here and 1 standard deviation here, we are only able to cover 68.26% of the output. When we go 2 standard deviation away from mean, we are able to cover 95.44%. When we go 3 standard deviation away from mean, we are able to cover 99.73%. So it matters a lot that inside the specification limit, how much standard deviation we are able to cover. Up to 3 standard deviation, we are able to achieve 99.73%. Now think about it. If you move more forward, 4 standard deviation, 5 standard deviation, then you will be able to cover a lot of units, or the defects will reduce a lot. Now we have to approximately 0.27% of the defects are there. When 99.73 is achieved, 0.27% are defects. But when you cover 4 standard deviation, 5 standard deviation, these defects will lower a lot. Now, tell me, is this process capable? Is this process capable? Answer is no. Why? Because mu plus minus 3 standard deviation is going outside the specification limit. It should come inside, but it is going outside, and that is why the process is not capable to produce what we want. Just change one thing. This is lower specification limit, LSL, and this is upper specification limit. Change the same thing everywhere. Because lower specification will go below your average, right? And upper specification will go above it. Now, this process is not capable. Why? Because our natural tolerance is going outside the specification limit, and hence your process is not capable. It's a bad process. It is producing a lot of defects. Next comes this situation where, if you notice, exactly your mu plus minus 3 standard deviations covering inside your upper and lower specification limits. This is a capable process, a good process. But think about it, if you are able to cover more than 3 standard deviation, if you notice, it's up to 3 standard deviation, then also we have some area. That means we are able to cover more than 3 standard deviation, then to your process is better. Your process is capable and it's better than what it was earlier. So when our natural tolerance limit and upper specification, lower specification limit ends at the same place, it is treated as capability is equal to 1. We are capable, but equal to 1 only. We are not able to improve more than that. We are not doing anything extra over and above mu plus minus 3 standard deviation. That is why our capability is 1. Why capability is 1 and how to denote capability is equal to 1? Lower specification limit is equal to mu minus 3 standard deviation, and upper specification limit is equal to mu plus 3 standard deviation. At exact this point, your upper specification limit is coming, mu plus 3 standard deviation, and at exact this point, mu minus 3 standard deviation, your lower specification limit is coming. And that is how you find out that your capability is equal to 1. Now at this point, you are only able to cover mu plus minus 3 standard deviation, which means that only 99.73% of the output will be of good quality, but 0.27% will be defective at this time also. Now what does it mean? It means that if I take total 10 lakh outputs, if I take total 10 lakh or 1 million output, then 99.73% of the output will be good, but 0.27% of 10 lakh or 1 million will be equal to 2700 units, which is defective now also. Even after covering mu plus minus 3 standard deviation, we are producing 2700 defects per million. Is it good? Better than what statistical quality control was able to do, but not good for an organization which is working at a very high level, which is working with a lot of customers. It is not at all good for them, because for them, they want to achieve 100% quality products or zero defect, and that is not possible with this process capability. And that is why Six Sigma was introduced. Six Sigma, the final stage. Now, if you notice the name, now though I think you might have understood that what does Six Sigma means. So earlier in our process capability, we are able to achieve only up to plus minus 3 sigma. But when we say 6 sigma, under this specification limit, we are able to cover normal distribution curve up to mu plus minus 6 sigma. And that is why it is known as 6 sigma. Now, by the 1980s, industries realized something. A process could be stable. A process could be capable. Our process is stable. We understood it from statistical quality control. Our process is capable. That means mu plus minus 3 standard deviation is covered inside our specification limit. But still not world class in quality, because even if your capability is equal to 1, there are 2700 defects per million opportunities. And that is also not a world-class quality which our companies want to achieve. Typical capable process where capability is equal to 1 had around 2700 defects per million. We already have seen this. Too many errors, too much waste. A lot of errors, a lot of waste is there. And why are we saying too many errors? Because think about it, if your organization is small, then though it will be okay. But if you are working with a lot of customers every day, if every day you are working with 10 lakh customers, think about it, 2700 are not satisfied. And these 2700 not satisfied customer can lead to a lot of more customers which are not satisfied now. Why? Because customers, when they find something bad in the product, they are going to tell it to everyone. And this can lead to a bad image of the organization. And that is why 2700 are also treated as too many errors and too much waste. Expensive rework is required for this 2700 units and inconsistent customer satisfaction. In the 10 lakh customers, 2700 customers are there who are not going to be satisfied properly. So this is what Motorola found out. Motorola wanted dramatic fewer defects, and this formed the foundation of Six Sigma. So if you notice, whether it be TQM, whether it be statistical quality control or process capability, all of these were introduced in Japan. So after World War, Japan was very heavy on improving the quality. Then came this US company Motorola. They said that why only Japan will improve the quality? We will also improve and will take it to a much more better level as compared to what Japan was taking. And that is why Motorola introduced the Six Sigma level of quality. This formed the foundation of Six Sigma. Motorola in 1986 introduced this Six Sigma. Six Sigma pushes variation control to the extremes. We are taking it to the extremes. A Six Sigma process produces not more than 3.4 defects per million opportunities. In 3 Sigma, you had 2700 defects per million. But with the help of Six Sigma, only 3.4 defects per million are happening. Now, how this 3.4 came? Is it similar to how we calculated for 3 Sigma? So, if I tell you, we calculated 3 Sigma with the help of our Z-score table. And with the help of Z-score table, we got the value that 99.73% of the output is good and only 0.27% is not good. And that is why 2700 defects per million opportunities are rising. If in similar fashion, I calculate for 6 Sigma, then it is going to come 0.002 defects per million opportunities. In the same fashion, when you check Z-score of 3 Sigma, you got 99.73. When you check for 6 Sigma, it is something like 99.99666%, somewhat like this. And that is how this 0.002 defects per million opportunity is coming. Think about it. Here 2700, here just 0.002 defects per million opportunity just by increasing 3 standard deviation more. Let me just tell you, even if it looks like only increase by 3 standard deviation, but it's very hard to move from 3 standard deviation to 6 standard deviation. It's like, think about your marks. It's easy it's easy to get up to 80. But to get up to 100, you need to work a lot more than how much you worked from 0 to 80. You need to be very clear about everything. In similar fashion, up to 3 standard deviation, so it is good to achieve. It is hard, but not as hard as it is to achieve from 3 standard deviation to 6 standard deviation. Okay? And here we are able to achieve 0.002 defects per million opportunity. But why we are writing it as 3.4 defects per million opportunities? I'll let you understand that. But for now, treat it as 0.002 defects per million opportunity. What is 3.4? We'll understand later. How? How are we able to achieve this 0.002 defects per million opportunity? By designing the processes so that the process mean is in center and we are able to cover plus minus 6 standard deviation inside the specification limit set by the customer. So the same diagram will be made as we made earlier. But now what happens? Now we are able to cover, this is let's say mu, we are able to cover 6 standard deviations here and 6 standard deviations here inside our specification limits. And that is why we are calling it as Six Sigma. Meaning, extremely small variations are there. We understood that 0.002 defects will be there per million, which is extremely small. Extremely high consistency will be there every time. Whenever we are making the product, we are making it as same, exactly same as we were doing earlier. Almost all units fall well inside customer specification, because 0.02 is very less. 0.002 defects per million is 2 defects per billion opportunities. In million, though, it's 0.002. If you take it in billions, it's 2 defects per billion opportunities, which is like almost every unit is coming inside the specification limit. Six Sigma is not only statistical, it is a philosophy, a way of thinking. Change in mindset is very important if you want to achieve Six Sigma level of quality. You need to change your mindset from defects are normal to defects are unacceptable. A management approach, because top management also gets involved in this, because without top management you will not be able to achieve this much quality. A structured improved method, we follow a step-by-step process which is known as GMAIC. What is this? We will understand it later, but for now understand that it is a step-by-step framework to improve our processes. A company-wide culture is required, not limited to production. You need to apply it everywhere, then only you can achieve that Six Sigma level of quality. Now you know what is known as Six Sigma level of quality. We have understood it in a very must way. Now, what is Sigma? What is Sigma written with 6? Mathematically, Sigma is the standard deviation of the process we understood. It measures spread or variation. How much variation is coming in the process, we measure that. If low standard deviation is there, low standard deviation means when we are drawing our normal distribution curve, every variation is near each other. When we say high standard deviation, then variation is a lot. Okay? Here the variation is shrinking the curve. When variation increases, the curve also spreads. What is better for the organization? We want to shrink the curve, right? We want to shrink the variations. We want to lower the variation. And the lower the variation, the better it is for the organization. So, low standard deviation process outputs are tightly packed around the mean, and this is much better for the organization, because as low as the variation will be, more good output will be generated. More standard deviation will be covered inside the specification limit of the customer. High standard deviation leads to widely scattered output, and badly scattered output means a lot of variation is there. And if variation is high, you will not be able to achieve that Six Sigma level of quality. In quality terms, Sigma level means how many standard deviation you are able to fit inside the specification limit set by the customer. So when we say 4 standard deviation, that means we are able to cover up to 4 standard deviation inside the specification limit of the customer. When we say 6 standard deviation, we are able to cover up to 6 standard deviation inside the specification limit set by the customer. More Sigma, as more the Sigma will be, lesser will be the probability that product crosses the limit, and defects will also become fewer. Now you can also say that, ma'am, why stop at 6 Sigma? Why not go 7 or 8 Sigma? Because 6 Sigma itself is able to produce approximately 0 defects, right? 3.4 defects, if I take the exact number, which is 3.4, we'll come to that number, that how 3.4 is coming. But the thing is, 3.4 per 10 lakh products is very good or much better than 2700 which we were able to produce in 3 Sigma. So why stop at 6 Sigma? As I told you, for marks, it becomes easy to get up to 80. But when you want to achieve up to 99, it becomes very complicated. You need to work really hard for that. But when you want to achieve up to 100, it takes a lot more efforts. And that is why we are only stopping at 6 Sigma. We are not going far than that, because it will take much more efforts as compared to the benefits it will give to us. What does 6 Sigma mean statistically? Let's start from a pure normal distribution with no mean shift. Now, what is mean shift? We'll understand it later. For now, we are understanding that what does 6 Sigma mean statistically. So assume process is centered, mean is equal to target. So your mu is your center. Specs are plus minus 6 standard deviation from the mean. So mu plus 6 standard deviation will be on one side and mu minus 6 standard deviation is on the other side. If your lower specification limit, which is set by the customer, is equal to mu minus 6 standard deviation and your upper specification limit set by the customer is equal to mu plus 6 standard deviation, this is known as your 6 sigma, because you are able to cover 6 sigma inside your specification limits. In a perfectly centered normal distribution, probability of a value lying beyond plus minus 6 sigma is extremely small. If your everything is centered, if everything is as per 6 sigma, then to your output being defective is equal to 0.002 defects per million opportunities. From standard normal distribution table, if you take the value of z score of 6, it comes to be this, which is equal to 1 in a billion. But I already told you that the z score table tells the value of one side only. But if you want to know the two sides value, then you only need to plus the value which has come here. So we'll plus this number with this. So, or you can do multiplied by 2. You will get the total of all the area, which comes to 2 in a billion, which is also equal to 0.002 defects per million. But 6 sigma, as used in practice, does not use this pure 6 sigma. We don't use this pure 6 sigma where 0.002 defects per million opportunity comes. We say it as 3.4 defects per million opportunities. Why we are saying this 3.4 defects per million opportunity? Because of 1.5 standard deviation shift. Now what is this 1.5 standard deviation shift? You need to understand that processes with time shift their mean. So for now, my process is able to produce the mean here. But after some time, your machine will be aged, right? The machine working right now is in its most efficient manner. This is new machine, but with time it will age and hence machine will somewhat change the output. As it is producing now, it will not be able to produce exact same output later. And it happens in most of the organization, most of the machines and tools. And that is why you will not be able to produce the mean exactly at the same place. This mean will shift. Now, how much shift will happen? So, when Motorola understood or researched on it, they understood that in a longer period of time, it can happen that your mean shift up to 1.5 standard deviation. So, this mean can go up to 1.5 standard deviation here or up to 1.5 standard deviation here. This can happen. And if this happens, then what will happen? Let's just understand this with the help of this diagram. So here we are able to cover our 6 sigma limits, and that is why 0.002 defects will be there per million opportunity. But this is only for the shorter period of time. In a longer period of time, there can happen 1.5 standard deviation ka shift. And if this 1.5 standard deviation ka shift happens, then earlier this was your mean, but now your mean has shifted 1.5 standard deviation to the right. It can also shift to left, but now we are taking just an example that our standard deviation, our mean shifted 1.5 standard deviation on right. Now what will happen? If you notice, from mean to this specification limit, what is the difference now? Half, 1, 2, 3, 4. So 4 plus half, that is equal to 4.5 standard deviation shift area is there. And if I go on this side, then half, 1, 2, 3, 4, 5, 6 and 7. That means 7.5 standard deviation is covered here, and here we have 4.5 standard deviation. If you check the value of z score of 4.5, it will come to 3.4. It will come to 3.4 defects per million opportunity. And if you check for 7.5, then so it covers up to 100% only. So it is approximately up to 0 defects per million opportunity. So if this side is 0 and this side is 3.4, I'll add both of them and it will come to 3.4 defects per million opportunity. And that is how 3.4 defects we are saying. Because it's 6 sigma, it can happen that in a longer period of time, organization's mean shifts from mean, the normal mean, to 1.5 standard deviation shift. It can happen on this side or on this side, but even if it happens on any of the side, the values will be same. 7.5 will have 0 and 4.5 will have 3.4. Hai? So at max, even if this 1.5 standard deviation shift happens, 6 sigma is able to achieve 3.4 defects per million opportunity. Hai? That is why 3.4 defects per million opportunity is mentioned. Now this is the situation of 6 sigma. But think about that process capability wala situation where you are only able to cover up to 3 sigma. Here also, in short period of time, your process is treated as capable. But the thing is, in long period of time, that 1.5 standard deviation shift can happen. And if that shift happens, then on this side, you are able to cover half and 1. That means 1.5 standard deviation. And on this side, half, 1, 2, 3, 4. That means 4.5 standard deviation. So 1.5 standard deviation is equal to 66,807 defects per million and 3.4 defects per million for 4.5, which is equal to 66,810 defects per million opportunities. Think about it. Just by this 1.5 standard deviation shift, now your same process which was earlier capable is now producing 66,810.4 defects per million. Can you now say that your process is capable? Answer is no, because this is a lot of defects. This can lead to a lot of damage to your brand. And that is what organizations don't want. And that is why it's very important for the organization to apply Six Sigma if you want to achieve a good quality, give an excellent product to your customers. Done. Now, if you notice, whenever this shift happens, our mean becomes near to one specification limit and it goes far away from the other specification limit. So there are very less chances that here you are not able to achieve the output because it became very far from the specification limit. Your normal distribution curve has become very far. Similarly, here also if you notice, our normal distribution has come a lot near to this area but very far from here. So chances of getting defects here becomes very less. That is why whenever we have this 1.5 standard deviation shift, we only check the defects which we are going to have near our mu. The line which is near to mu, we check the defects only of this side. Done. Now, let's see what our book says. The famous 1.5 standard deviation shift. In real life, processes means drift over time because of drift means gradually shift or moves over time. Why they shift? Because tool has wear out, temperature changes according to seasons, the temperature changes, right? So the temperature change, material change, human factor, machine aging. Due to all of these, there can be shift in your standard deviation. Motorola engineers observe that even very well controlled processes can gradually shift without anyone noticing immediately. No one will notice it immediately, but the shift can happen. They studied high performance manufacturing processes and concluded that over the long period of time, a process mean can shift by about 1.5 standard deviation from its original centered position. So they said in short term, process is centered at mean, but in longer period of time, there can be 1.5 shift which can happen to left or right. It's not necessary that it will move forward. It can move backward also. So now instead of 6 sigma between the mean and nearest spec limit, we effectively have only 4.5 standard deviation because that is the near area, right? Because 1.5 eaten away by shift. Short term we'll call it as 6 sigma. In long term, it is just 4.5 sigma. How do we get this 3.4 defects per million? We already understood that this shift is happening, and that is why now Z score will be calculated for 4.5, which comes to 3.4 defects per million. And if you calculate on the other side, which is 7.5 standard deviation, then it comes approximately up to 0 only. So 6 sigma with a 1.5 mean shift assumption gives 3.4 defects per million. This 4.5 long term, but 6 sigma short term is the standard 6 sigma convention, and this is the standard 6 sigma, which we call it as 6 sigma with 3.4 defects per million. Now, short term versus long term, so we already understood. This is written here. You can read it once if you want to. Now moving forward, why do they still call it as 6 sigma if effective distance is 4.5? We तो already understood that 4.5 sigma is the real one. 6 sigma is just name of it. Then why are we calling it as 6 sigma and not 4.5? Because our process should be designed to cover 6 sigma. Then only if there is any shift, we will be able to get up to 4.5 sigma. We have to make our processes, design our processes such that our process is 6 sigma capable. Then only in the long term, we will be able to achieve up to 4.5 sigma, which is 3.4 defects per million. Still call it as 6 sigma because original design of the process is as per 6 sigma opportunities, right? Now, sigma levels and DPMO table shift. This shift has been shown here. Sigma level, in the short term, we call it as 2 sigma, but in the long term, 1.5 shift can happen, and that is why it will be known as 0.5. So 2 sigma minus 1.5 is equal to 0.5 sigma. Now when 0.5 comes in, we'll check only of the side, we'll calculate the z-score of only of the side where 0.5 is coming, because the other side is now of 3.5, right? Think about like this. 2 sigma here, 2 sigma here. So total we are covering 4 sigma. But the thing is, when this 2 sigma shift by 1.5, so this becomes 4.5 and this side becomes 3.5 sigma. Now this side has become far away from the specification limit and this is very near to specification limit, and hence this is only calculated. So if I calculate 0.5's value in z-score, it will come up to 3,08,000 defects per million opportunity. I'm not talking in percentages because z-score tells in percentage. That percentage will be converted and then you will get this 3,08,000. How you will get it? So we understood in case of 3 sigma that 99.73% is the z-score percentages. After this, we get the defectives. So 100 minus 99.73 is equal to 0.27%. And now with the help of it, we calculate that 0.27 into 10 lakh, that is equal to 2,700 defects. That is how it is calculated. But for now, we are not doing that. We are just knowing the final defect, what will arise. So for 3 standard deviation, if this shifts, then 1.5 sigma will be the effective one, which leads to 66,800 defects. Similarly, if you go forward, you'll find that in 6 sigma, 4.5 sigma is the real one, and that is why 3.4 defects per million opportunity comes in. Now for reference, I have given the z-score if you want to look at it. So if z-score is 1, it comes to 15.8653 on the right tail, on the right side only. So if you want to know of the both side, you need to just multiply it by 2. If you are covering only up to 1 standard deviation, you are going to have 1,58,655 defects on one side only. You'll multiply it by 2, so it will come around 3 lakh. It's a lot. In 3 sigma, we cover up to 1,350 in one side into 2, which is equal to 2,700 defects per million. Similarly, on 6 sigma, if you notice, this is 0.000986 into 2. If you'll do, it will come to 0.002 defects per million opportunity. But we already understood that this is not effective. The effective is 4.5 sigma, which is 3.4 defects on one side only, because the other side has become to 7.5 standard deviation, which is equal to 0, approximately equal to 0. Done. Now with this, we have understood everything which was needed for 6 sigma. Now comes the theory part, which we have to write an exam. I hope you understand what 6 sigma is and what it does, why we are specifically reading it. I hope you all understood that. Now let's move forward to what we have to write an exam. So what is 6 sigma? 6 sigma is a method. Who created it? Motorola created it. Why they created it? To improve processes by removing the defects. We are not focusing on reducing the defects. We are just trying to remove the defects completely. A defect means product or service that does not meet the required specification of the customer. That is what defect is. If you are not able to fulfill the requirement of customer, that will be treated as defective product. Although Motorola formalized it in 1986 is the time when 6 sigma was introduced. But its idea came from older quality system only. Quality control, total quality management, zero defects. All of these are the ideas through which this 6 sigma was developed. Next, what 6 sigma believes in? 6 sigma is based on 3 main beliefs. First, reduce the variation. We want to make sure that our product becomes consistent. We are getting consistent result every time whenever we are producing the output. So if a process gives different results every time, quality suffers and you will not be able to get Six Sigma level quality. Six Sigma focuses on making results consistent every time. Everything can be improved. Any process, manufacturing or business can be improved, measured, analyzed, improved and controlled. No need of applying Six Sigma only to the manufacturing part of the organization. You can apply it everywhere, wherever you want to improve the quality. Everyone must support quality. Long-term improvement is only possible when the whole organization participates. Especially top management should support it, because without top management support, you will not be able to use Six Sigma properly. Next, why it is called Six Sigma? Six Sigma refers to a highly capable process that produces almost no defects. We can also tell our reason, which we understood earlier, that this is called Six Sigma because we are able to cover up to Six Sigma inside our specification limit on the right side and on the left side of the mean, and that is why we are calling it as Six Sigma. A Six Sigma level process has less than 3.4 defects per million opportunities. How this 3.4 defects came in? Because with time, if I calculate for Six Sigma, so it will come to 0.002 defects per million opportunity. But the thing is, with time, the process can shift. 1.5 standard deviation shift can happen in a longer period of time. And after this 1.5 standard deviation shift, we have 4.5 standard deviation on the nearest side. And if I calculate for 4.5 standard deviation, it will come up to 3.4 standard deviation, 3.4 defects per million opportunities. Gives 99.99966% of the defect-free output. This is extremely high quality, right? Next, what Six Sigma tries to achieve? Six Sigma aims to bring all processes to this level of quality. The Six Sigma level of quality we try to achieve for every process by reducing variations, preventing errors, using data to find the root cause why this particular problem is arising, making processes stable. That is achieved through statistical quality control. We will also try to make our process capable, but not only up to 3 standard deviation, but up to 6 standard deviation. We are trying to make our processes predictable and efficient. It works in any area, whether it be manufacturing, finance, IT, hospital, everywhere you can apply this Six Sigma. Now, we understood that Six Sigma tries to achieve up to 3.4 defects per million opportunities. But the thing is, how Six Sigma will do that? Till now, we were only understanding that what Six Sigma is all about. But how Six Sigma is able to achieve that level of quality? Let's understand that. For that, Six Sigma uses 2 different methods. The first one is DMAIC. This is used when we want to improve our existing processes. And the next one is DMADV, which is used when you want to improve your new process or product. Both are inspired by Deming's Plan, Do, Check, Act cycle. What is Plan, Do, Check, Act? Do you remember? First plan what you are going to do, then implement it, then check whether the implementation of the solution which you applied is working or not. If it is working, then act on it, make it as standard. If it is not working, then act on it and retry another solution, right? This is Plan, Do, Check, Act cycle. Somewhat PDCA is the inspire for DMAIC and DMADV. What is DMAIC? It is used mainly when the process already exists. So DMAIC improves a current process that is not performing well. What are the steps of it? First, D is define what you want to achieve with this. Next, measure what currently is happening inside your processes. Then analyze all the problems which you have inside your processes right now. Improve, find different solutions and implement it. If that solution works, then control, that means check whether everything has been implemented properly or not. Okay, everything has been working as per planned or not. First, define. Set goals, clear goals for improvement. So what you want to achieve from applying this DMAIC, you need to define that first. It can be anything, like you want to fulfill the customer need, or you want to achieve something related to company, like reducing the cost. What you want to achieve, first define that. Next, measure how the process is working right now, so that when after applying this DMAIC, you can see what improvements you have achieved after. So if you want to know whether we improved or not, we need to measure what we are doing right now. Then only we are able to compare and find out whether we improved or not, right? Next, analyze. Find the real cause of the problem, why that particular problem is arising. What factors affect the process? How do they relate? Which one actually creates defect? What are the factors due to which this defect is happening? Next, improve. Fix the process using the insights from analysis. You understood the problem really well, right? Now, by understanding it really well, you can improve. That means find different solutions to solve that. You will use design of experiments or different types of tools to test the best solution. This is one kind of tool. There can be many different tools which can be used. Now, what is design of experiments? Here, we check different factors or apply different factors together to see what impact they have. So, let's assume we are making bread. We want to achieve softness in bread. So there are different factors which affect the softness. It can be over temperature, baking time, yeast quantity. So instead of checking everyone separately or randomly, design of experiments creates structured combination of all of them. Oven can be at low temperature and baking is short time. Oven is at low temperature, baking is taking long time. Oven is at high temperature, baking is taking short time. Oven is at high temperature, baking is taking long time. So it's just two of the factors have been taken together. You can take all the three, or if you have more than that, you can take all of them together and see what happens if they change together. What will happen? You can measure the softness for each to understand that which one is best for the organization. This is how design of experiment works, and through this we test and find out the best solution. After finding out the best solution, you will implement it. After implementation, you need to control. That is, make sure improvements stay permanent. Whatever improvement you made, make sure that improvement stays permanent, and for that we need to control the process. Set up control checks at different places. Run pilot tests. That means just apply that particular improvement at one place. If it works well, apply in the whole organization. Will monitor the processes continuously and prevent the defect before they occur by controlling, by checking that everything is happening as per the solution or not. This is DMAIC when you want to improve your existing process. First, define, measure, analyze, improve, and control. Now, if you want to create a new process, you can use DMADV, which is also known as DMIADV, used when a new process or product must be designed. DMADV is used when the existing process cannot be improved enough and we need a new design. First, we will define what we want to achieve with the help of DMADV as we were doing in DMAIC. Next, we will measure. In DMAIC, we had earlier processes. So we measured what is happening right now. But here what we will measure? What our customer wants. So first we will identify what all things we want to achieve with this particular process, and then we will measure it in numerical terms so that we can achieve that particular output or particular efficiency. Next, you will analyze. That means you will find different solutions and find out the best solution which can achieve your output or which can achieve the efficiency which you want to achieve. And then we will design that process so that it can work in real life, and we will verify whether everything is working properly or not. Now, define what goal you want to achieve with your new design. It can be your customer needs or the company goal. Next is M, which is measure and identify. We don't have any other process which is working already. So now we need to identify things that we want to achieve and then measure them, like critical to quality factors. We need to fulfill customer requirements, right? But customer says that I want fast delivery. They don't measure it. They don't tell it in numbers. So what CTQ will do? CTQ will define it in numbers. It will measure the requirement derived from voice of customer. So whatever our customer is saying, we will measure it in numbers so that we can actually achieve it. We'll find out what all product capabilities we want to achieve, what all process capabilities we want to achieve, and what all risks are there. We'll measure all of them and identify all of them. After this, analyze. Develop different design options, create high-level design, and check which one is performing best. In our DMAIC also, we were doing analysis, but we were analyzing the problem. But here, we are finding out different designs. We are analyzing different designs so that we can find out the best solution. After finding the best design, build the detailed design, optimize it, Create simulation. Simulation means you can create a dummy model of what your process should look like, so that you can check or work on it and see whether it's actually working or not. And then we'll create a verification plan that whether this process is working or not, how we will check it, how we will verify it. Now, last process is verify, where you'll check the design if it's actually working or not. For this, you can run on pilot mode. That means you'll first try it once and then apply it to the whole organization. Test how this particular process is performing. Implement the new process. Hand it over to the process owner. If the process is working completely fine, you'll hand it over to the process owner. Done. So simple one-line definition is DMA-IC fix existing processes, and DMA-DV creates a new process or product that is defect-free from the start itself. Now, if you want to do this DMA-IC and DMA-DV, it is not a work of one single employee, because a lot of things are there in Six Sigma, and that is why different peoples are there with different responsibilities in Six Sigma. So we are seeing key roles in Six Sigma, what all are the people involved in it, and what all are their roles, responsibilities inside Six Sigma. So Six Sigma project involves data analysis, process redesign, cross-department coordination, financial impact, cultural change. A lot of things are there. So one person cannot handle it, and that is why responsibilities are distributed. There are 7 different roles in Six Sigma. The first one is executive leader. As you can see, he is the CEO of the company who will give vision that what we want to achieve with the help of Six Sigma. He is going to give that. Next comes champions. They are senior managers who are the one who will make sure that Six Sigma is implemented properly in the organization. Next comes master black belts. They are like the guide or coach who will teach everything or train the employees about Six Sigma. They are full-time guide or trainers of the Six Sigma. Next comes experts. Experts will, if the organization involves a lot of supplier, a lot of customers, different countries you are working, you want military level standards, then you need to involve these experts who will coordinate everyone all together. If you have different suppliers, customers, you have different types of standards, different countries, they will be the one who will coordinate and make sure that Six Sigma becomes applicable everywhere. Next comes black belt. They are full-time workers who will actually implement Six Sigma, because champions have to make sure that Six Sigma is implemented properly. But who will implement it? Black belts will implement it. Now, black belts, green belts, both of them are being trained by master black belts. Even the champions are trained by master black belts. But the thing is, this master black belt will train champion only on the strategic level, like how they need to decide which strategy should be implemented. But this master black belt will train black belt and green belt on how to apply the statistical tools, how to analyze the data, right? Now, these black belts are full-time workers under Six Sigma, whose work is only to apply the Six Sigma or achieve the Six Sigma level quality. They are the one who is going to implement the Six Sigma in the organization. Next comes green belt. They are part-time Six Sigma workers. They normally do what is the normal work in the organization, but in part-time, they also handle or support black belts in their work. Next comes yellow belts. They are not at all trained in Six Sigma. They have very less training. They just help whenever there is need. Whenever there is need for black belts and green belt, a lot of work is there, then they can take help of yellow belts, who are the normal employees of the company, who just help the Six Sigma and black belt and green belt only when they require it. Done. So these are the 7 different types of roles inside Six Sigma. Let's understand them one by one. We have already understood that is only what is written inside. Let's just once read it all. Executive leadership, which is CEO and the top management, who is going to give us the vision for Six Sigma, that what we want to achieve with it. They give resources, support and freedom, because without that, worker will not be able to achieve Six Sigma level quality. So resources, that means money and support should be there from the top managers, and the workers should also be given freedom. Then only they can find innovative ideas to solve the problems. Without them, Six Sigma cannot succeed, because who will support the workers? Who will give freedom to them? If top manager is not supporting, Six Sigma can't work in the organization. Next comes champions, who are the senior managers responsible for overall Six Sigma implementation in the company. Who are senior managers? They can be plant head or departmental heads. They select the right project and ensure all department follows Six Sigma smoothly. They mentor black belts, because black belts are the one who are going to implement the solution, who are going to actually find out the solution and see what all solutions are working for the problem which we want to solve with the help of Six Sigma. So they are the real workers. So black belts will be mentored by champions. At GE, that is General Electric Company, these champions are known as quality leaders, which shows us that it is not necessary what name is used, it is necessary to follow that particular role, even if the name has been changed, as General Electric changed the name to quality leader. Next comes master black belts. These are full-time Six Sigma experts and coaches. They train and guide champions for strategies and governance aspect, not in detailed statistical tool. For detailed statistical tool, they will train black belt and green belts who are actually going to work. They focus on the technical side like statistical tools. They are going to teach these tools to black belt and green belt and make sure Six Sigma is applied correctly everywhere. They do not run projects themselves. They just coach or guide the black belt and green belt about how to apply or implement Six Sigma in the organization. Experts, mainly in aerospace and defense industry. Why they are needed? Because subsystems involve multiple suppliers, different countries, complex technologies, multiple grade standards, military grade standards, and that is why it's very important to coordinate improvement across entire system. And for that we need experts. Why it is mainly in aerospace and defense industry? Because Raytheon was the company, American aerospace and defense manufacturer company, who was the first one to use this experts category, and that is why it is mainly used by aerospace and defense industries now. They work across multiple teams, suppliers and customers. Their role is to improve large systems that involve many departments and locations. Raytheon was the one among the first to use this role. Next comes black belts. They are the full-time Six Sigma workers or the leaders of the project. They are going to lead the project of Six Sigma. They work under master black belts. They are full-time Six Sigma project leaders. Their job is to solve complex problems, deliver major improvements and guide green belts about what all things green belts have to do. So black belts play a leader role of implementing the Six Sigma process. They lead DMA IC or DMA DV. They analyze the data. They identify what is the root cause behind the problem. They implement the improvement, deliver measurable financial impact. What is measurable financial impact? They deliver the success which is measurable. What was the situation before implementation and after implementation, you can measure it financially. Next, report to champions. Champions, if you notice in the champions also we understood that they mentor black belts. So black belt will report to champion what all achievements we have made. And they are the problem solver. They are the one who will solve the problem and achieve the vision which has been set by the top management. Green belts, employees who work on Six Sigma part-time along with their regular job. They support black belts in project. They handle smaller improvement tasks like department level improvements they will handle. Next comes yellow belt, who have basic Six Sigma training. They know the concept but do not lead the project. They may support small tasks if needed. Done. These are the different categories divided in Six Sigma who work all together for applying DMA IC or DMA DV. Next, now we have a case study to understand how DMA IC can actually be applied in the organization. So Ford applied Six Sigma in their organization. How they applied or for what purpose they apply, let's just understand that. What was the problem for which they want to apply Six Sigma? Ford uses a scorecard system with green, yellow, red signals. Green, on or above target, that means which is a good thing. You have done everything correctly, that will be treated as green. Yellow, slight concern, like slightly problematic, maybe slightly below target. Red is serious issue which need to be solved as fast as possible because it can lead to a lot of losses for the organization. So in 2009, Ford noticed that body paint consumption for Focus and Kuga cars was red. That means it was a serious issue for the organization. High consumption was happening for painting these cars. Past consumption in 2007, it was just 3.74 kg per unit, but currently we are consuming 4.18 kg per unit, which is 0.44 kg per car increased as compared to what was happening in 2007. Now, ma'am, it's just 4.44. Why we are making it a big concern? The reason is they are not just painting one car. They are going to paint millions of cars. And as they are painting millions of cars, it becomes a lot of quantity. And the paint is expensive. And that is why this 0.44 kg per car leads to a huge amount of increase in cost for the organization. And the solvent which is there in paint, if you use more paint, the solvent will have more impact on the environment. So we try to use as less as possible. Next. So Ford decided to start a Six Sigma black belt project to fix this. Now, the project can be of three types in the organization. Six Sigma black belt project, Six Sigma green belt project, and Six Sigma yellow belt project. Yellow belt project is mainly where yellow belt people will be involved. Very small improvement is required. Green belt, a little more improvement is required. Black belt project where a huge impact is there and a lot of improvement is there. Then we use a black belt project. So it was a large scope, cross-functional, high impact, full-time leadership job, and advanced tools were to be used for solving this. Hence, we used black belt project to fix this. Forming the Six Sigma team. Ford has many trained Six Sigma people. They have 50 plus black belts and 400 plus green belts. Black belts will be the leader for solving the problem. So black belt leader was decided that Martin Fisher will be the one who will lead this project. Then he selected a project team for the same on the basis of skill, experience, responsibility, and ability to work in teams. Then they applied DMAIC method. D, that means define what all things you want to achieve. The team identified who is affected, internal or external customer, who all are affected by using a lot of paint. How they identified? Using SIPOC. SIPOC is supplier, input, process, output, customer. We'll look at all of them and identify that which one is affected due to this. Next, they set three goals. First, they will reduce paint consumption, which will lower the cost. They will improve customer satisfaction, that means better process capability. They'll reduce environmental impact, that means lower solvent will be used. The expected benefit was cost reduction will be very high, could save $1.5 million annually if they are able to reduce this paint consumption. Customer satisfaction will be medium. Environmental saving will also be medium, around 50,000 kg less VOC per year will be produced. What is VOC? VOC is volatile organic compound, which is the harmful compound which evaporates in air, and it's harmful for us, it's harmful for environment. So whenever we use paint, this compound evaporates in air. So if you use less paint, the compound will go lesser in the air, and that is why as we are aiming for using less paint, we will be able to reduce this by 50,000 kg. Done. Next, measure. In measure, what we do? We measure what is the current situation, right? So the team collected the data. They checked critical factors such as how much paint we are using on a daily basis, paint film thickness, that is how much thick paint we are painting in our car, paint used by robots, and paint used by manual painters. First time throughput rate. What is first time throughput rates? How many units are produced on a correct manner on first time itself. No need of reworking on them. Paint equipment condition. What is the condition of paint equipment which we are using? After measuring, they analyzed the situation. The team analyzed all the problems which we are having, like why this particular problem is happening. For that, they used three different types of tools. First, 5 why analysis. What is 5 why analysis? You'll go deeper into the problem till the time you don't find what is the root cause behind it. And for going deeper, we'll at least ask 5 times why. If with the help of 5 times you are able to solve, good enough. You are able to find the root cause, good enough. If you're not able to, you'll keep on asking why till the time you don't find the root cause of the problem. Cause and effect diagram, which is fishbone diagram. So fishbone diagram shows On the face of the fish, we show the problem, and on the bones of it, we show the causes due to which this problem is arising. So we are doing cause and effect analysis so that we can understand what are the problems and what are the reasons behind this problem, so that we can solve these reasons to solve the problem. Next, test for each factor. Test whether a variable actually affects the problem or not. We did that as well. After doing all of these, they found two major root causes. First, a damaged solvent recovery valve. What is solvent recovery valve? So it controls how much paint will go, how much paint will come out of that paint machine. That solvent is damaged, and if it is damaged, more paint flows than required. It increases the consumption, and that is why the consumption is a lot in the organization. Next, a robot problem is also there. So the lift gate robot. What is lift gate? The back door that opens upward in the car, that is known as lift gate. So the robot is painting that lift gate is actually using a lot of paint. Manual painting is more efficient as compared to using robot there. What is the solution developed to improve? So this is the improve phase. What all happened till now? First, we defined what we want to achieve. Then we measured the current situation. Then we analyzed, find out the root cause of the problem. Now we are finding different solutions to solve those problems. So for the solvent recovery valve problem, we have 4 different solutions which we tested to find the best solution. The first is replace plastic valve with the stainless steel valve. Create an automatic valve checking system so that valve is checked every time, so that even if that valve get damaged, we can change it with the other one. Check valves every week manually. You can also check the same. Eliminate the solvent recovery system. You just eliminate or remove that solvent recovery itself. So it will lead to a lot of environmental impact. So it's not good for the organization. Next, so best solution was replace plastic valve with stainless steel, because by doing that you are able to do 45% improvement just by applying this one. Now for the robot issue, so robot was using more paint. So for this we tested 3 different solutions. We can use a new cleaning program so that robot can work properly. We can change the robot process to manual painting, or we can upgrade to electrostatic paint system. What is electrostatic paint system? When you use magnetic effect to paint the car. Car is negatively charged, paint is positively charged, so they get a magnetic effect, they get connected by themselves. So due to this, less paint is used, the car gets a good coverage also, so customers are also satisfied. So what was the best solution which they applied out of 3? They applied manual only painting for interior parts with saved 0.28 kg per unit. Why they didn't apply this electrostatic? It is good, but it is not cost effective for the organization, so they decided not to upgrade to electrostatic. Next is implementation. After finding out the best solution, you need to implement that. So for implementation also, they followed 3-step plan. First, think how implementation will be done. You will make a plan for the same. Then act, implement the changes, and then control, ensure improvement stays. So this is the last process, which is control, DMAIC. After improving, you will implement the process, or you will implement the new design, and then you will try to control it. They also handle resistance by training and giving data to stakeholders. So their employees and stakeholders might resist for the same. So for employees, they trained them, and for other stakeholders, they provided data to make them sure that this particular thing will actually work. Final result, the project was a big success for the organization. Ford saved $5 lakh annually. Paint consumption dropped from 4.18 to 3.3 kg per unit. The team met and even exceeded all the project goal. Ford won recognition in ASQ's 2011 Team Excellence Award. To maintain results, Ford created a monitoring system, and that is what control is all about. Monitoring that everything is working properly or not. Shows real-time paint consumption, include all paint booths, is part of ISO 9000 audit, so that as per ISO standards also we are checking everything is working fine or not. This ensures the process stays within the limits, and that is how, with the help of DMAIC, Ford improved its paint consumption or reduced its paint consumption and reduced its cost also. This is how organizations apply DMA IC and DMA DV. Now with this, we have completed our Six Sigma topic. But we have something remaining, which is writing all of it. But are we going to write everything we studied today? Answer is no. Whatever we are writing in our summary book is for exam. So the topics which we studied specifically from exam point of view, we are going to write that only. So it is going to be around 1 to 2 page only, not more than that. Now, write the heading, which is Six Sigma. Who created or who developed it? Created by Motorola. When they created it? In 1986. Why Motorola created this particular system? To improve processes by removing defects. Now, what is defect? If product or service does not meet the customer's required specification, then it is treated as a defective product. This Six Sigma was developed in 1986, but it was developed on the previous available ideas or the quality measures which was used by the organizations, right? So, its idea came from older quality systems like quality control, TQM, zero defects. What Six Sigma believes in? It believes in reducing variations. It believes that everything can be improved. And everyone must support quality. When we say everyone must support quality, what does it mean? It means that everyone in the organization should support, but especially top management. Because without them, you'll not be able to apply Six Sigma in the organization. Everything can be improved. Any process, manufacturing, or any other business process, you can improve that with the help of Six Sigma. Reduce variation, how you will do that? By focusing on making results consistent. The output should be consistent. If output is consistent, that means variations are less. Why it is called Six Sigma? Due to highly capable process that produces almost no defect. So with the help of Six Sigma, we are able to produce almost no defect, and that is why we are saying it as Six Sigma. But there is a specific reason why we specifically call it as Six Sigma, not 4, 5 or 3. What is the reason behind that? Because we make our processes such that Six Sigma variations are covered inside customers specification limit. So Six Sigma, up to Six Sigma, we are covering inside customer specification limit, and that is why we are specifically calling it as Six Sigma and not any other number. Customer specification limit can be upper and lower specification limit. So when LSL, that is lower specification limit, is equal to mu minus Six Sigma and upper specification limit is equal to mu plus Six Sigma, this is what Six Sigma is. It shows that we are able to cover inside our specification limit up to Six Sigma variations on both the sides from the average. Next, a Six Sigma level process has less than 3.4 defects per million opportunities. Million is 10 lakh, This can also be written, defect per million opportunity can be written as GPMO. In long term, 3.4 defects per million opportunities in long term, in short term, though it is 0.002 defects per million opportunity. Has up to 0.002 defects per million opportunity in short term. Now this 3.4 defects per million opportunity in long term, how it is coming? Due to 1.5 standard deviation shift, 1.5 standard deviation shift can happen in processes in long term. Hence, 3.4 defects per million opportunity comes from 6 minus 1.5 standard deviation, which is equal to 4.5 standard deviation. And if you check the Z score of 4.5, then on the basis of it, you will get only 3.4 defects per million opportunities. Gives 99.9966% defect free output. Which is extremely high quality, Now, what Six Sigma tries to achieve? First, it tries to reduce the variations, prevent errors, find the root cause and solve the problem so that it doesn't happens again, and make process stable, capable, predictable and efficient. Works in any area, whether it be manufacturing, HR, IT, service. You can apply at any area this Six Sigma. Next, Six Sigma methodology. So we have two different methods under Six Sigma. First is DMAIC and DMADV or DMIADV. You can call it as DMADV or DMIADV because in measure step we have measure and identify. Now, DMAIC is for improving existing processes. And DMADV is for creating a new process. First, let's focus on DMAIC. First, D is define. Next, measure, analyze, improve, and control. Let's write first about define. In define, we set clear goals. For improvements. These goals can be related to customer needs or company related goals. Next, measure. Measure how processes are working right now. We'll check how our process is working right now. We'll measure everything about our current process system. So you can compare before versus after. For comparing before versus after, we should have before's measurement. And that is why this measure step is followed. Next, analyze. Find the real cause of the problem. Why this particular problem is happening, find the real cause of it. How to find the real cause? First, check what factors affect processes. What all factors are there which are affecting our process? How factors are related with each other? Then check which one actually create defects. Which factor is the one which is actually creating the defect? So we are doing analysis to find out the real cause behind the problem and then we'll improve it. Fix the process. How to fix your process? Using tools like design of experiments. What is design of experiments all about? It's used for finding the best solution. So, considers the impact of changes in different factors together. What is the impact of different changes in different factors, if they are taken together, then what happens? We'll check that. And the one which works perfectly, the change which works perfectly, we'll choose that as the best solution. Now, after that, we'll implement that best solution. After implementing, you need to make sure improvement stays permanent. This is DMAIC. Next comes DMADV, which is also known as DMIADV. This involves first define, next measure and identify, next analyze, then design, and then verify. First, define what the new design must achieve. What we want to achieve with the new design, we'll define that first. It can be customer needs or company goals. Next, identify and measure. What we will identify and measure? Critical to quality factors, which is will convert voice of customer on a measurable term. This is known as CTQ. With the help of this, we are trying to convert measurable requirements from voice of customer. Next is we want to achieve product capability, process capability. What are the product capability or process capability? We'll measure that and we'll measure the risk in the particular new process which we are creating. Done. Next, analyze. Here we will check different design options. Or we will develop different design options. Plus, check which one's best. Next, design. Now, whatever design is finalized, we'll develop it in a detailed manner. Build the detailed design. Plus, prepare verification plan. How verification will be done? We'll prepare a plan for the same. Now the last step comes, which is verify. Check if design actually works or not. If design is actually working or not, we'll check that. Plus, implement the new process and hand over to process owners. Hand over the new process to process owner. Done. This is DMAIDV or DMADV. Next comes key roles in Six Sigma. This is the last part which we are writing here. Key roles in Six Sigma. As one person cannot handle all roles, responsibilities are distributed, as one person cannot handle all roles of Six Sigma, and that is why responsibilities are distributed among different members. Now here we have 7 different categories. So let me just divide them with the help of table. So 1, next 2, 3, 4, 5. We have to make more space. We need 7 blocks. Six and 7. The last blocks are small enough because we need not write more about green belts and yellow belts, right? For others, we have to write a lot, and that is why we need more space. Now, first one is executive leadership. Executive leadership. Who is executive leader? CEO or the top management? What they do? They set the vision. Plus, they are the one who are going to give us resources, right? Give resources plus support plus freedom. And the Six Sigma cannot work or cannot succeed without them. This is the top management or the executive leader. They are the one who set the vision. Next is champions. Who are they? They are the senior managers of the organization, the plant head or the departmental head, responsible for Six Sigma implementation. I can write Six Sigma like this, है ना? Why to write Six Sigma in a more detailed manner, है ना? We'll write it in short. Implementation. Plus, select. They select the right project to work on. And ensure departments follow Six Sigma smoothly. Plus, they also mentor black belt and they are also known as quality leaders. So, champions and quality leaders are the same thing. Who gave this name? Quality leaders. General Electric gave this name. Next is master black belts. Master black belts. So they are full-time Six Sigma experts or coach. Full-time Six Sigma expert. They train and guide champions, black belts and green belts. Plus, they focus on technical side and make sure Six Sigma is applied correctly. Next, after master black belts comes experts. Who are the experts? They work across multiple teams, suppliers and customers, plus their role is to coordinate improvement across entire system. Used mainly in aerospace and defense industry. Done. After experts comes black belts. Black belts work under master black belts. And they are full-time Six Sigma project leaders. Their job is to solve complex problems, lead DMAIC and DMADV, deliver major improvements, guide green belt. This is about black belts. Next comes green belts. Works on Six Sigma part-time. They are part-time Six Sigma workers. Along with regular job. So regularly they are doing other jobs in the organization, but part-time they also help Six Sigma black belts. Support black belts. Next comes yellow belt. Having basic knowledge of Six Sigma may support small improvement or small task if needed. If there is any need by the green belts or black belts, they can support, this yellow belts can support small task if there is any need of the same. Done. With this, we have completed our Six Sigma. Now, in the next class, we are going to do questions related to quality cost, the practical questions of it. Now, what I want from all of you, I have already given you 3 questions in homework, which you need to try once. Question number 1, 2, 3. Now, I want you to try question number 4, 5, 6 also by yourself. Do it in the rough copy. No need to do in your main class notes, because in the main class notes, we'll do all of them in our next class. But I want you to first try it yourself. If it is done or you don't know what is happening, just try it once. You write the question, you understand the question properly, you write what all things you understood. Just do that once, so that in the next class, when I tell you how this question should be approached, you get a better understanding of it and you are able to retain that for a longer period of time. Done? So question number 4, 5, 6 is also your homework. Try that once. If you are not done question number 1, 2, 3 also, then do that. Do that. Question number 1, 2, 6 is your homework. You need to try that once. If it's done, good enough. If it is not done, you're not able to understand it, then also good enough. But you need to read at least once the question. Done. Now we'll meet in our next class. Till then, happy learning, everyone. Radhe Radhe. Bye bye. Bye bye, everyone.